Hi, and welcome to the Electronic Show this Wednesday. Uh, I have finally received the filaments that I was waiting for. Finally, it was pretty quick actually. I ordered it late Monday. They say they have next day shipping, so I could have them by Tuesday, but only if I ordered before 12 o'clock, which seems reasonable enough. So technically, it only took one day to get here. So I finally received my PLA. And as you know, I print a lot now. So today's episode is not going to be teardowns today, but I'm going to talk a lot about printing in the progress therefore. Because 3D printing is a lot of fun. You probably think it's fun too, because you're probably thinking about doing those things yourself. And I know a lot of my audience like electronics and like to build encasements for their electronics projects. And a lot of my audience also interested in movies and games and of course likes to have figurines printed out, and so it's a really cool thing to be talking about. And in a way, this is a great chance for you and me to learn together how to do 3D printing properly, how the different materials work, and basically what the pitfalls and the good things about 3D printers. You know, we're experiencing this together every day, every step of the way. And we do some reviews of old stuff, and we look at retro games and video games and consoles, sometimes radio amateur stuff, sometimes components, sometimes we build something, and sometimes we repair something. So welcome if you just joined the show. We're live. It's 1800 hours Central European times. Don't forget to subscribe so you get a reminder. Let's go to the chat now and see if anybody has joined. Hi Peter. And hi Tim, it's good to see our regulars coming back, and welcome back to the show. Hope you guys are okay and everything is fine about you. Let's go back to the issues at hand. We can start now that some of our faithful regulars are already joined, so it's easier to just get started. The longer the show will actually last. Peter, first of all, I have a little message for you. And that is that the camera that you so graciously sent me for parts or teardowns, etc., is actually working perfectly fine. There's nothing wrong with it. I decided to test the battery inside of it, which is here, of course. This battery here. And it was completely dead. This is a 3.7 or 3.6 volts, 680 or 630 milliamp lithium-ion battery. Since you didn't send the charger with the thing, I'm assuming that what could have been wrong with the camera from your sister would actually be that the charger was defective or something like that, or the battery, because I had to revive the battery, if you like. And I used this little baby here, which is a professional laboratory power supply, which can supply a constant current of my choice. So I decided to pump a lot of juice into this one in order to make it come alive again. And as by magic, it actually became alive. And I decided to actually begin making a charger myself, because when I looked on eBay, the charger for these things are ridiculously expensive. If you're not buying some Chinese clones, which I don't trust because those things can catch fire. Sorry about that, but there's a lot of producers of really cruddy, cheap Chinese charger. We often just find a diode and a couple of resistors and stuff like that connected directly to the mains, and those things are a fire hazard, so watch out for those things. There is a reason why the originals cost like $50 or something like that. That's more than a camera will cost on eBay today. So I was starting to make I want to make an Arduino based charger. I haven't come to that part yet because there's a lot of programming, but I have 3D printed a pretty smart case that actually holds the battery in place like this, and the wires are of course going to go along here and down to some extra components I'm going to place inside of here, and basically become a USB charger, because this camera itself cannot be charged by USB. It is too old-fashioned for that. But it was 14 megapixels, and that's more than I have on my camera, so I was thinking about just using that for thumbnails of the show, etc., etc. So that was kind of useful. Thank you for that, Peter. So it gets new life after all. But this is how I made it. I made some small connectors here, And that means I also made a spring-based connector here, which can hold the battery in place. And it's made with PLA, and it works just fine. You can see it's flexible. It's just 3D printed, so I didn't have to add some extra parts. So what I basically did was just insert this one in here into its sockets like this. A little bit tricky. And it sits perfectly fine in there. And I connect this and basically charge it. You can see that I've set it to 4.2 volts, and the reason I'm setting it to that is because that's the factory specifications for recharging a lithium-ion battery. That's 3.6 volts. And you also have to be really careful when you're using constant current, because you're not supposed to be charging batteries, especially lithium-ion batteries, at that, because they need to be pulse charged, and they need to have all kinds of temperature sensors and current sensors, because they will change rapidly and you can risk a fire hazard. They can in fact explode if you overcharge them. You can risk having internal plating, as it's called, etc., etc. So it's very important to be careful. I can do this because I have a laboratory power supply, and as you can see right here, right now, it charges with roughly 220 or 200 milliamps right now at 4.2 volts. The meters, you should not trust internal meters. You also have to, if you do this, you also have to connect a multimeter in order to check what the battery's actual voltage is when you're charging it. It is not supposed to surpass 4.2 volts. Right now it's probably at 4.1 volt or something like that, which is perfectly okay. It's supposed to go all the way up to 4.2, and it will should not drop past 100 milliamp if you are charging a battery like this, a lithium with a power supply like that, where you have full control. Don't do it with amateur equipment, because you can risk a fire and you can risk serious damage by doing that. So I cannot recommend doing that. But I let this one charge for roughly 50 or 60 minutes, and I've been testing the camera and it works just fine. Just insert it here, and you can show this to your sister if you like. Perfectly functional camera, as you can see. Even recognize my face and everything else. And it takes pictures exactly like it should. Let's take a picture of the progress I'm doing right now printing. There you go. And it has a last taken picture function right here. Let's see if I can zoom up. Yep. There you go. So the camera works just fine. It's a good little camera, actually, just fine. So, job done. Let's go to the chat and see what you guys says. Right, this is kind of like a self-made, homemade charger though. So yeah, right. Hello Nagy, and welcome back to the show. We were just talking about repairing this unit, the camera that I got from Peter, which turns out to be probably just the battery or the charger, because I made a new charger for it. Just 3D printed that. Of course, it took a couple of hours to design one that fits exactly the battery and the etc. and stuff like that. Well, it was kind of, it had to be done, you know. I found that the batteries, I could revive the battery, and the camera was just fine. So I was thinking, why not? I might as well do that. Okay, today's subject is, of course, surprisingly going to be about 3D printing, because I just received my filaments from Credo, Credo.se, and they were just as fast as advertised. I just Googled my way to this. I don't know those people, but they seem to be very fast and really good customer service and stuff like that. And I get nothing from them for endorsing them or anything like that. I have no idea how good their filaments are. I am currently testing their filaments right now, and I paid full price just like everybody else. It was relatively cheap. It's maybe a couple of dollars cheaper than my regular brand, but it's supposed to be premium filaments, and they're really, really big. There's like 1 kilo rolls. I can show you that, just so you can. I put 3 of them up. So let's go to the close-up cam. You can see here they're really big rolls. Another thing that I like about them is that they are transparent, so it's easy to see what kind of color or how much left I have of each color. I can't see that with the Flash Forge. So you can see the Flash Forge ones are the original ones that are actually made for this printer. They cost roughly half the price of these, so it's almost the same price. The PLA is relatively cheap, but this is supposed to be a much higher quality. So I am currently printing and testing that and conducting some tests. So we're gonna find out if that holds true or not. I have made some tests I'm gonna show you to you guys today, so it's going to be kind of interesting. One of the colors I've received is glow in the dark. I've also received silver because I was thinking, since I'm mostly printing with really good results using gray, because obviously gray just looks a heck of a lot better than just printing it at white, because you can hardly see the details in the white. You can see them in real life, but when you want to show it off in any kind of angles or any kind of lighting conditions, you would definitely want to print it in gray. They seem to call this silver too. Flash Forge, this is the original Flash Forge material. They just call it gray. They don't call it silver. So it turns out it might be actually silver. It depends on how you define the color yourself, because it's very silver-like. I bought 1 kilo of what they call silver from, the brand is called Sun 3D Filament, eSun. This brand here. And it cost roughly 289 Swedish kroners. I think that roughly translates to $30 or something like that for a kilo. So it's not so bad. It is 1.7 of some 1.75 millimeters PLA, and they call it silver. But if you ask me, this color here doesn't look any different from this. It is shiny just as this one, but I think they just called gray for silver just to get more money or get it sell it or something like that. I haven't tested this one, so let's check that out later and see if it actually gives some good results. I'm not going to do that today because I'm already testing 3 colors. And as you know, 3D printing takes an awful lot of time, so it will take a while to print these things. All right. This was the test character. This turns out to be a really good test character for 3D printing. Because as you know, I had an accident like this, where a tree actually came off and fell down. And would you believe it, that happens on every single model I make of this particular print. Not this particular character, but this particular print. So when I printed a small version with the new material, I have to go to the close-up camera because it's simply too bright for this one. This is the flesh colored I've just bought. The same thing happened to this one, and I had to abort the entire printing process because the tree just fell down here as well. But what surprised me is the enormous quality of this new material. As you can see, the detail is absolutely insanely amazing. The smallest details came out. Even the small sleeves in there came out perfectly well, and even my name tag and everything else came out pretty well. I'm gonna go to close-up here and see if I can convince my camera to actually focus, because as you know, it doesn't always focus, but I have to work at it and see if I can convince it to focus closer. See what it does. There you go. As you have to understand, this is less than 2 centimeters wide. So the printing of that hand, and it hasn't completed the foot there, but you can see the name, and you can see the details on the toes, etc. See if I can get it to focus. Come on, focus. It's actually quite amazing when you look at it, especially on the details on the hands right there. So it does a pretty good, decent job. This is the new material. This is the flesh colored material that I have been working on. And the flesh colored material here is melting at a much lower melt point, so I can't print it at 220 degrees, which is the norm. So I had to change the setting down to 200. I've actually changed it down to 195 now, because I'm printing a new character to see if the trees doesn't fall off again, because I think it was just too soft. That's why it's falling off. Let's go back to the chat and see what you guys have to say. There are indeed copper filaments as well. I've been thinking about buying that copper filament, but the problem is I'm kind of cheap, and it's kind of expensive. The copper filament, and the cheapest place I've ever found cost like, I think, $30 just for 250 grams. So I'm gonna wait until that comes down a little bit in price. That's a little bit hefty. I can get a whole kilo of silver for that. So I'm not gonna do that yet, but maybe I might do it in the future if someone wants a print like this maybe and they want it. I'll do it, of course. So yeah, well, Maggie, I'm glad this show is helping you to convince you to 3D printing, because actually, honestly, it does everything you can imagine as an electronics freak. I mean, seriously, I just made a charger that fits the Sony batteries, you know, as I showed earlier. If you missed that, Maggie, you can wind back the show, go back and watch it later. And it actually fits this one just perfectly. And I'm working on making an Arduino charger for the Sony battery. So just because I can. And I was thinking about making a multi-charger maybe that fits all those batteries for those small little cameras. Just because I can. So that is the amazing thing with 3D printing. I mean, you can build anything you want. If you have an idea right there, you can just do it right away. And but right now I am testing the various filaments. Another filament I've just received is the see in the dark or glow in the dark sort of filament. When I first got the roll of filament and I put it up against the neon lights, I couldn't see anything. I mean, I went into my bedroom with it where it's really dark and nothing was glowing. But it turns out you may have to print with the material in order to activate the glow color. I don't know why and how, but it turns out when I printed this little thing, it worked just fine. And for some reason, this material were a lot stronger, but also a little bit more bulkier. So it works just fine with this really hard to print test that I have here, that I've made. It's not a test that you can download. This is my character created by me. But it turns out to be a ridiculously good test. How to make perfect settings for your 3D printer. Forget Benchy, man. That's the little boat you can print for benchmarking. This one could be the new benchmarking, because if your printer can print this, then it can print anything. Because the trees will here fall off. Noodle's head is really big and it poses a crazy detail challenge for your 3D printer. And I have actually noticed, to FlashForge defense, I have noticed that my prints gets to be a lot better than a lot of those Prusa printers I've seen on the YouTube. Every single time I see somebody use on the i3 Prusa or A6 or A8, etc., they get okay results, but it still looks like it's homemade. You don't get perfectly clean prints. This one is very close to really clean prints. So just when I do these industrial designs, etc., I get really insanely clean prints. And you don't see that a lot with those home-built printers. Sure, they're a lot of fun, but they seem like they have to work an awful lot in order to get those good results. I haven't worked that hard to get those results I get. For example, Noodles here was printed almost completely without any strikes or stripes. I haven't been sanding this character at all, but he was printed so cleanly you wouldn't believe it. Although in quite high settings, but still. And it took like 7 hours, but still faster than a lot of others. So it's not bad. Not bad at all. So, but I'm definitely going to check out other 3D printers in the future, because this is definitely a thing I'm going to be doing myself, Maggie and Peter and everybody else. I'm going to be doing a lot with 3D printing. It's obvious. I mean, it is a shame to let this thing just stand without printing. So I'm trying to print as often as I can, because it's a shame not to let it work. That's why you hear a little bit of noise in the background now, because I'm still printing. Hopefully the sound isn't clipping. If it's clipping too much, do tell me, because I have to try to set the settings I have here. You can see it on my screen here where I monitor everything. And when I speak, I can see that I don't reach this level here too much, and the last level is here. So yeah, that's basically why. This character that I just printed is like a 1.5 centimeters big, so it's really small. It's just as small as my little thumb, as you can see here. But even that came out quite amazingly detailed. You can even count his little toes. Unfortunately, this camera is not sharp enough, But you can see even the little toes and the details of everything just came out. And this is a glow in the dark version, miniature version of this this character right here. But you have to, of course, when you print this, I mean, you have to clean it. So I have a whole bunch of tools that I'm using all the time. I'll show you that. I have a whole bunch of tools here, as you can see. These are essentially, if you're old like me, you probably need these, or astigmatic anyway. And all of these tools are necessary in order to clean the plate. You know, when you are 3D printing, you're going to have to clean that plate. And you need to cut everything loose instead of, you need to file small parts, stuff like that. All of those things are going to be necessary. So you might as well have those tools by your side when you are doing 3D printing. So just to, you know, all of these things. This little spatula of mine broke today. This is the one that comes with the printer. Ooh, crap. But it still works. I can still use parts of it. Maybe I can 3D print a new one. I have a stronger material that I might test later on, so I can actually just print a new spatula. But we'll have to see how that will hold up. I'll see if I can make something better. I'm not sure I can actually show you this 3D glow item today, because I need a lot of dark in here in order to see it. Let's see if it's possible. Let's do something. Let's see if I can make it glow temporarily or something. Yeah, maybe. If I turn down all the lights, I'll be right back. I'll go to the chat so you guys can talk a little bit. I don't know the sculptor printer. I haven't tested that, so I can't really tell you how that is. I just unplug this, and I'm probably going to have to turn off the other light as well in order to good thing this microphone comes with a long wire. Alright, that should do it. See if you guys can see if this thing glows in the dark. Probably have to turn off the monitor as well. Let's see if we can. They make awfully good web cameras today. I have turned off all my lights in here, and the only glow that's coming is coming from the 3D printer and the monitors right now. Let's see, you should probably see something. Yeah, it glows, you can see it. You'll see it glow right there, I think. Hello Terry, welcome to the show. We're just talking about 3D printing right now. And right now we're testing glow in the dark filaments and see if it works. It works just fine. This actually glows in the dark. So yeah. That filament worked just fine. I'm going to turn back the lights again because this is probably going to get a little bit jumpy. We could always go to the full camera. I kind of want to look how this looks in the dark. Wow, that is actually kind of amazing. I mean, it's a little bit slower now, the web camera, but I gotta hand it to Logitech when it comes to low light conditions. I'm actually sitting here talking to you guys with only the monitors itself lighting it, and I've dimmed them down to like 30% of the glow from the monitor. That's crazy, man. That's really crazy. Notice this still glows. You can kind of see it here. Yeah, it does. It works just fine. What it does. And now the focus actually works better. This little 3D printed noodles here is a miniature version of this one that I printed earlier. This is kind of cozy. I kind of like this lighting. Maybe we should keep it like this for a little while. It makes everything look kind of different, but the face looks kind of easier to watch as well. What do you guys think? That's kind of amazing, actually. Let's go to the close-up cam and see. I'm printing another character, as you can see right there, because I can't let the printer just sleep. But it's got to work all the time, of course, because get its money worth, right? Although it's quite cheap as to begin with, as it was. I mean, $500 for a super commercial printer like that. That's not bad. It's really big too. You know, it's half my body size, so it's kind of a big thing. But it's fun to play with. It's kind of amazing that it actually is this good in low lighting conditions. I didn't expect that at all. That was totally unexpected to me. Wow. That makes me reconsider how I'm going to put up my lights, because I have like 3 light sources here. I have one up here, which is supposed to cover my face and the stuff that I do here on the bench. And I have another one, like a 230 watt lamp above me to cover the whole entire workshop. And then I have another one that's roughly 100 watts in this direction in order to give different shades. And I've been placing all of those lights calculatively, to put it that way. I've been so the background here doesn't reflect into the camera, because you know there's a lot of glass parts here, and there's a lot of plastic parts, and a lot of screens that actually can reflect. I'm kind of curious of how the instruments are going to look in the dark. Probably pretty much the same, I think. Let's turn on a few things and see what happens. This was kind of fun. Oh wow, the instruments looks a lot better in like that light conditions. That's pretty interesting. Oh wow, because you can hardly see that stuff normally. That's pretty cool. Yeah, you can even see the numbers on the multimeter right there, and stuff like that. That is pretty darn cool. Let's turn more stuff off, just for, you know, for fancy, just for the fun of it. Let's put everything on. Probably going to use a lot of electricity. I hope I'm not going to blow a circuit right now. Let's put that one on too, just for fun. Let's put it all on. Oh, that one has a spectrum analyzer kind of receiving stuff. So put down the sound a little bit so you don't hear that. Yep. It kind of looks spooky. It really kind of looks a little bit spooky, but also kind of cozy. You're gonna a little staring candlelight next to it or something like that. Maybe during Christmas or something like that. I don't know. Yeah, it's kind of cozy. It's kind of gives them a certain mood. But yeah, of course the frame rate will be dropping. There's no doubt about that, because you know the cameras are now trying to compensate for the lack of lights, so it's going into night shot mode. But I'm still kind of impressed how it keeps the colors. I don't know how the colors are really going to look like, because my monitor is kind of shitty. I'm gonna have to buy new monitors when I get the money allows for it. But you know, I don't have tons of money, so I'm gonna have to use whatever I have. All the 3 monitors is basically monitors I've just gotten from the local. Well, you know, when they change their offices, they sell it out on Lions auction and stuff like that, and I buy it for like $20 or something like that. So I just use those things. And I really need a new gamer screen at some point anyway, but I haven't really decided which one to buy, and I'm a little bit cheapish, as you know, so I don't really want to give $1,000 to $1,500 for a curved gaming monitor. I already gave $1,300 for my HTC Vive virtual reality. That's enough for me for a long time, I can tell you that much. But yeah, this light setup is kind of cozy. Wonder how the print's gonna look like. It's gonna focus easier if I do that. Probably not. It's not gonna focus a lot easier than it usually did. The colors kind of look better on it. Yeah, I don't know. Maybe the white ones are easier to watch in this kind of light. Yeah, a lot. And I do mean a lot easier to watch. Still hard time focusing though. Yeah. Still have a hard time focusing. But yeah, it kind of, maybe this is the kind of light I'm going to have to use when I'm showing off my characters that I made 3D printed in white. But now you can see exactly what I meant when I said this is actually a really high quality printer. You can hardly see any stripes at all, and I have not been sanding this thing at all. This is just printed on a normal mode, but a little bit higher quality resolution, stuff like that, and it did just fine. Another thing that it actually did fine with is this was done really fast. This was printed in the fastest I can possibly print. 15 minutes or something like that. I'm not really sure how long I used, but it was just a test I did in order to see how accurate it is. And I have to say it is super accurate. I mean, when is the last time you saw a 3D printer on YouTube, especially not those Prusa ones, that can print something this clean without any stripes, and especially at on the 200 settings, which is the fastest you can go. So that's kind of crazy fast, actually. Let's go to the chat. Yeah, whatever works. That's right. Well, yeah, it would be nice. Actually, I would love that, because that, Peter, would be would make it able to remove a lot of the monitors, because then I can just use one long wide monitor. So I've been thinking about that, but I'm gonna wait quite some time until it comes down in price before I actually do that. I'm just checking out my 3D model now to see I'm not getting any threading. It looks really great so far. This time the supports are working better. I have been reducing my printing down to 195 degrees Celsius now, because the new filaments that I received from, what do I call them again? Sun? Yeah, they call it Sun. eSun, actually. This is the new filaments that I'm testing. And they seem to be melting at a much lower melting point. And they also give a lot more detail than the other ones I've been trying so far. And I didn't think you can get much better than this on a 3D printer, but obviously it is quite possible, just as long as you work with the settings and experiment with different speeds, different printing speeds, etc. Then you can achieve some pretty amazing things, actually. So wow to that. But it is amazing. Even despite I have seen the bad results people think is good results, you know, when they're working with those i3 Prusas or whatever they're called, they have a lot of stripes on them and stuff like that, striping. I think I'm gonna buy one with multicolor, you know, one with the 3 different colors and toning, just to see if I can experiment better results. I'm not sure about that. But I have 20 years of 3D modeling experience and a lot of electronics experience. It is possible that I may be able to do it a little bit more educated than your average hobbyist that is just building that for the first time or something like that. So I don't think it would be fair to say that the i3 Prusa or any one of the other ones that people build themselves are really that bad before I've actually built and tested one myself. I only have seen the stuff that people are printing on YouTube, and it doesn't look that impressive to me, sadly. But they're getting to be so cheap. At some point, when I have the budget, have enough work to do, etc., I will invest in one and see if they are as bad as I think they are. Most people don't think they're bad. They're really excited about it. And, hey, who can blame them? I mean, some of them buy them for $150 and put them together. And some of them buy the more expensive models for around $300 or $400 and put them together. And they get all these stripes in their printing, and they're happy with it. Fine, if you're happy with it. Exactly, but I'm a 3D modeler. My standards are perhaps a little bit higher, especially since I have been working for many years at advertising companies, which incidentally have been producing merchandise and knickknacks and gifts and stuff like that I have been producing in China. Not printing it myself, but I've done the 3D works and the STL files that has to be shipped to China, where it gets printed professionally and produced and molded and with injection molding and all that professional stuff. So yeah, let's go back to the chat and see if you guys have anything to talk about. You know, Tim, you and I, we really think alike. This sounds like a really good idea. Oh, Peter, that's pretty cheap, but that's quite amazing. Anyway, Tim, you and I, we think alike. I have been thinking about exactly the same thing. I'm gonna turn on the lights now because this is getting kind of dark for even me, and it was fun and all that, but you know, let's try a different lighting and see what happens. This is the top light. This is the top light, see what happens. Now it looks kind of ugly. Because now at least I'm sort of see more of my hair, which is very little, and less of my face. So now I'm putting on the face light, which is this one. I should have switches for that. And now all the colors are looking a lot more warmer. And of course, as you probably noticed, Peter, the frame rate is now much, much faster. But I'm still missing that extra light that I have in front here in order to make it warmer. But I'm just gonna, you know, yeah, you can see everything gets washed out when I have this much light. Because we're talking several hundred watts of lights in this studio right now. This is actually what the studios use. They use really hefty light, and that's why you sometimes see the people working, they're squinting like that, because you know you have to get used to that intensive light all the time. You know, just put Noodles back here where he stands. Gotta turn off these because they kind of make excessive noise, and that's kind of unnecessary. And they also draw extra power, which is equally unnecessary. Right. There you go. All right. Yep, let's see how far it's come when it comes to 3D printing, the new model. Wow, it's really detailed and nice. I have reduced it to 195 Celsius right now. And this is so low I shouldn't even be printing at that. And the software also has some issues because it seems to not be able to remember my settings every single time I'm selecting fine mode. So it just goes back to printing in normal mode. Interestingly enough, it heats my temperature settings though, and that's kind of important. But let's take a look. Let's see if I can sneak a peek, put the camera in here. As you can see, it's super finely detailed. So I wish I had a camera that was inside here all the time. Some of the printers actually comes default with a print cam. Just so you can live cast or show your friends your printing process. A lot of people on YouTube does that. That's pretty cool. But I'd like to, you know, get a little closer and just, you know, show the process. That's actually pretty cool. If you're wondering what those sticks are, those are the trees I've been talking about. Those are the things that are going to support Noodle's head, because he has a very big head, and if those fall off, we're gonna have those big problems that I showed you earlier in 3D printing, which I do not want to have again, because those are annoying. I just fixate my camera here. There you go, back to normal. Just as I showed you here, this looks quite pretty and all that. It was, but there you can see, because the trees that you just saw from the other print were falling off and breaking off. You know, the 3D printer cannot print out in the loose, thin air. So it needs something to print on. That's why it makes these trees. And as you get more experienced as a user, especially as a 3D printer user, you will be able probably to make those supports yourself. That's what I'm working on right now. I'm working on understanding how far the print head can take the plastic without melting before it reaches the next point. That way I can think how much I can space and how little of those supports I'm going to need, because essentially the less supports you use, the less plastic you're going to consume, which is, even though it's cheap, if you're using hundreds of rolls, I've been using almost 3 rolls just in 1.5 weeks, even it's quite cheap, and I've been printing tons of these, and it's still going to be money, you know, it's still going to cost money. I mean, the way I've estimated it so far, I'm going to spend like $100 to $150 a month just printing 10 or 20 of these. But it's a whole lot cheaper than ordering at Shapeways, because they take like, for a size like this, they take like $60 for a huge print like this. So if I printed like 10 of these, it will still be $600, and I couldn't possibly afford that. So printing it for $100, that's like a sixth of the price. That's like super cheap in comparison. So yeah, that's the way to go. And let's face it, you guys are probably not going to print a huge character like this every day. If you print something like this, just to hold your pens or whatever, just to hold your graphics pens or whatever, works just fine. It takes 5 minutes to print this little one, but it's of course very thin, as you can probably see. But it takes only 5 minutes to print that. And the one that I've been making here, as you know, with Arduino built inside, I've shown you this before, but if you're new to the show, I'll show you this before. I made this enclosure for it, TFT screen, and even the charger socket in the different colors. All of this were printed in just 2 hours. 1 hour to print this, and 1 hour to print that. So you don't have to spend a fortune on that. If you only printed this stuff, you can print like 30 to 40 enclosures in just one roll. And that's going to cost you to like maybe $1 for this entire setup. And that's cheaper than buying the Arduino. So if you're messing around with electronics at home and you're not afraid of getting dirty with a 3D printer because it's going to clog up, it's going to mess up, it's going to glue up, your spatula is going to break, and you're going to get nails that looks exactly like mine, you know, flaked to pieces by trying to break these things apart. If you're not afraid of that stuff, and you like to mess around with electronics, or you like to design characters, or you just want to print a lot of cool game characters, and you know, in your room or your house, then 3D printing is definitely for you because it's tons of fun. I found out that I'm going to probably spend years on doing this stuff. I'm just a noob at 3D printing right now, but I'm not a noob in 3D modeling. So get the difference right, because it's kind of they kind of go hand in hand. If you're good at 3D modeling, you're going to have a lot better success with 3D printing. So let's go back to the chat and see what you guys say. So what do you want a close-up from? Oh yeah, back to the Tim. The Mini C64. This is something I've been thinking about as well. In fact, I was researching that yesterday. I was thinking about, is it possible to put a Commodore 64 on Arduino? Not really. I found somebody on YouTube that claims to have done it with an Arduino Duo, which is roughly an 80 megahertz, not 18, but 80 megahertz Arduino, a 32-bit Cortex M3 processor, if I'm not entirely, it's an ARM processor. I do have one of those little gadgets myself. Let's see if I can find it. Yeah, I have it right here. I've actually connected to a TFT screen now because I've been testing it, see how fast it is in comparison to others. But yeah, this is a Dewey version. This is one more expensive version of, it's not the Mega, that's one that's expensive too, but it's the Dewey, which is even more expensive because it's like a really fast Arduino. But not even on this one I can run Commodore 64, because it turns out to be a fake. There was somebody just making a screen and with a little bit of flickering and making it look like they made a Commodore 64 emulator. So unless you actually wrote the entire code up from scratch, that is more like an emulation of the Commodore 64's programming and addressing and stuff like that. If you're emulating all the chip, if you're emulating the VIC chip, if you're emulating the SID chip, the sound chip, you know, etc., and all those things, you're not going to be able to do it on a 80 megahertz processor. You will most likely need a minimum of 600 megahertz, an ARM processor that's around 600 megahertz. Because I remember running that on my cell phone, which incidentally happened to have an ARM processor running at 600 megahertz. And even that one struggled at 18 to 25 frames per second. In all fairness, it was running a phone and an Android operating system at the same time, so yeah, it can probably be done, but I wouldn't go much lower than 600 megahertz. You can get development boards, for example, the Raspberry Pi, that runs at 800 megahertz, that runs 1.2, 1.5 gigahertz, etc., etc. You can probably use that, and in fact, that's a pretty good idea. I might actually get a Raspberry Pi just for that purpose and print like a miniature Commodore 64. Many years ago, I designed my own version of Commodore 64 as a portable Commodore 64. It went really viral and popular on the internet, but it's like 15 years ago, and I was young to 3D. I don't know where it is right now, so I'm not going to look it up. But this has been very close to my heart for many years. I've been wanting to do this for years. It would be fun. It's a good idea. I think I'm going to do that one day. And since I'm holding the Dewey in my hand right now, why not show you that? Because I did connect get 3D printed parts everywhere now. The whole place is becoming a mess with 3D stuff, which is not so strange considering how fun it really is. But let me connect this one to some power outlet in my short space I have here. Let's see if I can run this on 200 milliamps. I probably can. There you go. Should be running. See if you can see that. Okay, something must have failed. What has failed? This ran last time I checked it out. Have I been erasing something? Where's the reset button on this thing? This is a live show after all. Things are bound to fail once in a while. Oh, there you go. There it goes. It prints really fast. And you can see the color screen just works really well. And this is how fast roughly the Duo is. If we connect and I have an Arduino connected to this one running a test. I'm gonna have to take the other camera if I use the USB, so I'm not gonna do that. I don't have a USB power here, so you have to take my word for it. But it runs about 3 times slower than this one, but it also costs a whole lot less. The Nano here cost around $2 as a clone from China. This one thing as a clone from China cost roughly $15. So it's I don't know if it's worth 3 times the speed, 5 or 6 times the money, and that's just a clone. The original, you don't even want to know what the original cost is. Over $60 or $70 or something like that, maybe even more. You can get a lot of Raspberry Pis for that. So yeah, I've also been testing. I finally found out. I was talking on one of the earlier shows that I didn't manage to, for the life of me, to figure out how to use this really big high-resolution display. I still haven't figured out how to use the touchscreen, because I think it comes with a touchscreen. If you can see, there's some kind of I think it's capacitive touchscreen, because the other one I have is a resistive touchscreen, and when you touch that, you can sort of see the surface bend a little bit. If you look at the reflection, you can see the surface is slightly bending. It's difficult to see. You have to take my word for it. But this one is a really big display. I was hoping to use it for my first homebrew smartphone. So I've been testing that. See if I can run it with that cheap power supply. Yeah, it can. And as you can see, it is running high resolution and everything. Really beautiful display. And it's running on a 16 megahertz Arduino Uno, which is just a standard Arduino, really. This is just a $3 or $4 clone, and the display itself was relatively cheap. Relatively, it cost me like $6 or something like that, but it's a really nice high-resolution screen. For those of you playing along at home, this is a MCU friend 3.5 inch TFT screen. Yeah. So, still having fun with those things, and I'm probably not going to stop there, especially now that I'm preparing them for the enclosures I'm doing with the 3D printing. So this is going to be a whole lot of fun in the future. No doubt about that. Let's see how far it's come. Oh, it's almost finished. Well, almost, not almost. It says 85% complete. Let's check that out. Let's see how far it's come. Oh, or not. Wink. That's Noodle's hair. You're seeing him from behind there. He is the half-nude version, because I didn't want to use all the time with the clothes, because it takes forever to print that. So I just print him bare-boned like that. Almost finished. And, yep. Let's go back to the chat and see what you guys say. Yeah, the Raspberry Zero is supposed to be cheap too. I remember when it came out, they charged only $5 for it. And we're talking about David Braben's company, you know, the guy behind the Frontier Elite, the video game that was really, really popular back in the 80s, the space emulation program. But the Raspberry Pi didn't sell really well. It actually sold out immediately, But the problem is people are greedy. So a lot of people speculated on it, and they knew it was going to be popular. So they immediately bought all the magazines that came within the Raspberry Pi for $5, because they gave it away for free with the first Raspberry Pi Magpie magazine, I think it's called. And it sold out the first day within the first hours. And a lot of people were really shrewd, and they weren't interested in electronics. They just knew that this was going to be a hit. So they resold it on eBay for $150 for a $5 P. Yeah, that is crazy. But people bought it, you know, because it was new, it was popular and hot, and everything. Oh, I got myself the $5 computer too for $150. But that's people for you. If it has any news value, they're gonna pay pretty much anything. And the rest of us, like people like me, I was thinking, oh my God, I finally got a little supercomputer. Now I can perhaps finally ditch my Arduinos that cost $2, which is not a lot of money, but hey, they're only like 20 or 30K memory, and they're like 16 megahertz in speed. But the Raspberry Zero maybe was it 600 or 800 or maybe even 1 gigahertz? I don't even remember, but it was super fast in comparison, and only $5. But can you ever get it for $5? Go to their homepage, always sold out, and they refer to their retailers or resellers, and they're in backstock all the time. And I don't know if that's an artificial backstock, or if you can get it for $5, it's $30 shipping. Why do you need to ship something that is so flat? It is only the size of this. It is actually this small. You can put it in an envelope. It'll cost you £1 to send it uninsured. And let's face it, you don't need a $30 insurance on a thing that costs $5. So you can easily just send it in an envelope. But do you think they think like that? No, they're way smarter than that. Those resellers and those people who retail these things, they earn money on the shipping them itself. There's where the big money is. It's exactly the same thing that happens on eBay, except when you're shopping with the Chinese, because they kind of using substitute mails. But that's the thing. So I never buy those things because they end up costing $30, $40 each. So you're not going to get them for $5. I've never even heard about a person that actually got it for $5, unless they walked into that store in UK back then, which were incidentally the only place on the planet where you can get it for $5 or £5. Because if you buy a Magpie in Sweden, if you go to one of the stores in Sweden and buy the Magpie magazine, you pay 290 Swedish kronor. That's over $30 for the magazine alone. That's how much they upprice things around here. Markup is huge. Let's go back to the YouTube chat and see what you guys are saying. Yeah, I definitely think so. And I would, just for fun, try to see if I can get a second-hand Raspberry or something like that, or just buy one of the cheapest I can find, and put Commodore 64 emulator on it, on Linux, of course, and just let it run the 64 emulator, Frodo, I believe it's called, and just have fun with that. That's going to be a great deal of fun, I think. Yeah, let's do that. And 3D print a small Commodore 64. I had to rethink the design. I could be using this screen here for it, because this screen has the exact resolution needed in order to get the Commodore 64 natively correct, and big enough to to make a little keyboard here and stuff like that. And since the keyboard has a lot of keys, I'm probably going to cheat a little. I'm probably going to 3D print the keys, and I'm going to make a sort of fake keyboard on a PCB, where you basically just press some small metal buttons I can buy at eBay or something like that, just in order to customize it for that. That sounds like a good project. It could be a lot of fun to do during the winter. Make a small miniature Commodore 64, just for fun. Just because we can. So why not? It's a good idea. See how far it's come printing. Just for you guys who are just joining, the character we're trying to print right now is my little Noodles character. I am testing the new filaments that I have. Right now I am testing the human flesh colored filament, and I'm running as low as 195 degrees Celsius right now. And right now I'm looking for all kinds of new filaments to test on my printer because I think it's a lot of fun. I'm totally hooked to this. You can obviously get gold colors, brass colors, bronze colors, copper, as Tim was mentioning earlier, etc. And I'm currently testing the cheapest filaments with the biggest rolls that I could possibly get in Sweden. And it turns out to be pretty sweet quality, actually. I just need to learn how to use it at the right speeds, at the right temperatures, in order to get that smooth, beautiful finish. Right. That's almost there. It's 95%. There's 5% left before we're actually getting there. Those people at Credo is kind of sweet, though. They have a good personal touch, I think. Look what he wrote. He gave me a little bit of samples on new filaments. This is a filament called PET-G for temperatures 230 to 250, it says. And a Merry Christmas, Tommy. Greetings from Henrik. That's pretty cute. That's where I ordered my filaments. I've never tested them, but I just Googled them and found out they were, according to other hobbyists in Sweden, they were the cheapest and the really fastest you can possibly get here in the country. And they're right. I mean, I ordered after 12 o'clock, so technically it took 2 days, but practically it's just 1 day. So they delivered immediately, so that went really quickly. I was surprised how fast that went. So right now I'm testing the quality of these filaments to see if they're any good. So that's pretty interesting. I'm looking forward to try the blue one as well. You know, I bought a blue filament as well. Now look how big these rolls are in comparison to the old rolls, and you can see through them too. They're transparent, so you always know how much left you have of the rolls. This is really practical. This is something they really thought through when they made these things. But they have really different, wildly different temperature settings. Just look at this one. This has temperatures recommended from 205 to 225. While the other one, this one, the human colored one, has 190 to 220. At 220, everything just melted and became a mess, so I can't even use that. This one worked just fine at 220, but as you can see, well, maybe can't see, I'm not sure how far I can get this camera. You can see the surface is a little bit rougher. It's not as blank as all the other ones. The other one is much more blanker and prettier. And that also reflected in the final results. Also reflected in the final results because the glow in the dark one that I made, that glows in the dark, became a little bit rougher. Even though you can see the little details of the toes, you can still see that the plastic is somewhat rough, as you can see here. As in comparison to this one, where it's a lot smoother, and the print is much more detailed, even at lower temperatures like this. This is less than 2 centimeters. Print is super small. The head came off because of the trees that were falling off of support. The same thing was happening here. So I'm sort of trying to figure out how to make my own manual supports so that they don't fall off. Because normally they don't do that. I haven't had any problems with the other prints that I've been making earlier. But that's because the head wasn't going back like that. So there's obviously a lot of things to think about when working with 3D printing. Let's see what you guys say. That is a really, really good question, Tim. To be honest with you, I have not been able to do so. I've been trying to put it into pause mode, but I can't go back and change temperature. That is something I should be able to do. I'm sad to say that doesn't seem to be possible at all. It wants to cancel the entire print. That could be due to the fact that there is a whole ARM computer inside of the printer itself. And it's just using all of its processing powers to display the beautiful touch color screen that it has built inside. It has one of those, I'll show you. It has a built-in touch color screen. And the only function that it has while printing is showing the actual temperature. The toolbox is either showing me how to stop or pause or something like that. So I can only unload and load a filament with that toolbox. So far this hasn't been possible, but maybe it will come in a later firmware. I don't know. But I've heard it's possible to play some kind of open source software on it too. I haven't dared to do that yet because I'm just going the commercial way, because I'm thinking that the producer of this printer know a lot more about it than I do, and people out there do. So I'm sticking to proprietary for now, except Blender, of course, which I use to model the things. And that is, of course, open source. Okay, we have results. It's finished. Let's check it out. Give it a little wire here. Okay, that does not look too bad. That looks really high resolution. I need my glasses for this because I can't even see that detailed. It's more detailed than what I can see, actually. So let's go to a close-up and see what it says. Let's get this off. Use my half-broken spatula now. As you can see, I've been busy printing lately. I have printed on a raft in order to make it a little bit easier to remove. But I'm getting really good at sticking this one to the plate now. So now they become almost impossible to remove, which is something that my spatula can testament to. So I have to use one of these beautiful graphic kit here. But the only thing that I'm worried about using this one is that they can sort of destroy the entire plate here, because they dig into the material itself. So that's not a good idea. So I'm going to try to push this one flat into it so it doesn't dig into the plate itself. So I'm going to see if I can do that somehow. Yeah, that worked out just fine. Beautiful. Just what I wanted to happen. No problem. Nice. There's always a trick for DIYers, as you know. We can always fix these things. So I have to be a little bit gentle with this thing, because it's kind of... yeah, I like to clean up first. I always wait with the best for last. I like to make sure that everything is ready for the next production, because I don't want this thing to rest a single second. I want this thing to be producing and pumping out results all the time. And this is one of my secrets right now. I'm using a sandpaper in order to make the glue stick and get all the bumps away. And there's absolutely no need for re-leveling. I've been printing like 10 to 20 times in a row, and I haven't needed to re-level this thing at all, because it's really accurate. The mechanics is really beautiful, actually. And now the surface looks dirty, but it actually likes a dirty surface. The dirtier the surface is, no dust of course, the dirtier the surface is, the better it actually sticks. As you can see, I can hardly get it off. So people who are fanatically cleaning this all the time, I did that in the beginning and I got like really bad results every time I did that. But if I keep it really dirty, it actually gets printed really well each time. So let's pry it up, see what we get. I have to be careful, this is a really small model. Okay, the raft came up just fine. That I can breathe a little bit easier. I'm going to use the finer plier. So just break it off gently so I don't break other parts off. I can already tell you this model came very beautifully out. That is really surprising how I found the right temperature. 195 seems to be the perfect temperature for this thing. Maybe I can even try it a little bit lower, so I can easily pry off the smaller detail that is still a bit stuck here. Because it still seems like it has a few extra plastic parts that doesn't quite want to come off immediately. But patience, I'm going to show you this. It looks absolutely freaking gorgeous, I have to say that. It looks absolutely insanely gorgeous. I am quite surprised how well it actually became. Even though being super, super small, this one is so small. I mean, it's thumb-sized. And remember the last thumb-sized one I made didn't become that beautiful because it's a different material, a little bit more cruder. But this is the flesh tones that melts at much lower temperatures. See if I can get some dirt out of Noodle's ear. here, and that was just perfectly possible. This is the afterwork that is demanded of doing this. But that's perfectly okay. It comes up nicely, just as long as I do this right. The PLA is, of course, notoriously difficult to cut in or sand, just so you know that. And that's why it's also so incredibly brittle, but at the same time very strong. So before it actually becomes brittle, it will really not break. As I've shown you on the earlier shows, we've been trying to break them, and you can't break them just by tossing them or, you know, crashing them to the ground or whatever. You have to use a hammer or something in order to break them, because they will not break. They're really that good. Oh, I'm probably talking too close to the microphone, so I'm probably getting a lot of clipping. So I sound very enthusiastic because, of course, I am very enthusiastic about this. I really love this. I'm going to try an even higher detail next time, because this is good, but I think the printer can even do better. This is better than what I've seen on the net, though. I gotta tell you that. I'm gonna show you this. This is quite sweet. Maybe I should cut his mouth open a little bit more, because it seems a little bit restrictive by plastic parts. Because the printer has actually taken the time to create the detail of his mouth, even though it's so small that it's actually thinner than a strand of plast. It is thinner than the thinnest strand that actually extruded, so it actually deserves that detail, I think. So yeah, just gonna get rid of the. There was not a lot of spidering, cobwebbing right here now. This is surprisingly well done still. Very little of that. And the details became quite fine. Okay, I think that'll do it. I think I still see a little bit of cobwebbing here on his feet. Let's hold it up against the light so I can actually see what I'm doing. Because it kind of has the same color as my table. It's kind of like a flesh/wooden table look to it all. Yeah, didn't become too bad at all. Not too bad at all. All right, roughly cleaned. I'm going to show this one to you now. And as you can see, it came out really nicely and detailed, even the mouth. Head is a really complex thing to print for it, as you probably know. This doesn't really do it any justice. So see if I can get the focus properly here somehow. It's almost good. Let's shade the light a little bit, because the light is sort of making it light up too much. See if I can somehow show you this. That's better. Not really. Oh. You almost got it there for a minute. I wanted to focus on my face instead. Almost got it. Yeah, almost got it. You know what I'm gonna do? I'm gonna force Logitech to focus. There is a possibility to go into the settings here. I'm going to go into the settings, and I'm going to do this manually, just to really force it to do this. So let's do that and see if it works. Yeah, that's better. I haven't done that before. I should have that control open. It doesn't look that great when you look at it this close. When you look at it far away, it actually looks a lot better. But this is kind of like it's like a microscope mode now. Let's see if I can focus a little bit closer like that. Looks a little bit better now. needs a little bit of surface detailing, etc., etc. But you have to understand how small this thing is. Oh, it is as small as a my thumb here, basically. It's clinging on to for dear life on my thumb. Yeah, enough about that. Go back to our autofocus, please. Nope. There you go. Yeah, it kind of looks like cheese, doesn't it? So yep, we have a lot of different sizes now. Suddenly becomes different, different when you look at this thing in comparison. What a difference it is, huh? It looks so much differently. It's almost like, but it is still far away, you know, when you think about it. So yeah, I gotta tell you, I prefer these bigger sizes here. It's much more fun for me. It's a great way to test the accuracy. I'm still kind of wondering why this one became a little bit more accurate than the other ones. Maybe because it's quite a lot bigger. Maybe this is the size that I should be printing it at when I'm making those small ones. Let's go back to them. I should perhaps keep this open so I can actually do this every single time. Yeah, I should do that. I should actually have that up open in a special window. Let's go back to this. You can see this one is actually quite detailed in comparison. This one has really nice hands. Maybe not this close. If you look at this one has really nice hands, really nice details. While the other one here is actually smaller, but you can see the details are not really up there with the other one yet. If you look at the hands, stuff like that. Yep. Yes. All right, let's go back to the chat, see what you guys are saying. Well, we are actually 12 minutes past the hour we're supposed to be, but you know, I really think it's fun to do these things. And Nagy, it's, well, yeah, I could show it under the microscope. We can do that quickly. That's a good idea. Let's do that. Let's go to the microscope camera. There's already some threads there from the other. Let's look at it under the microscope. It's probably going to look really, really not detailed, but very, very plasticky, because this is like 20 times magnification, which is, there is his hand. Now you can see how it's printed. You can see it's very stringy there because, you know, yeah, very stringy. Understand the shakiness is, of course, you wouldn't even see the shakiness right now, but this is like 20 times magnification. So yeah, and here's the other smaller model that I made earlier. As you can see, this has a different consistency, and this is much less exact than the other model. And it looks much more a mess than anything else. That is because the consistency, here's the hand of the other one. This is a small glow-in-the-dark version I was showing you earlier of Noodles. Just show. This is actually the really small one we're talking about here. That looks, oh, I lost the microscope contact right there. But anyway, and the other one with the details was the one with this material on it, the human flesh material. So there's clearly a printing difference. For example, the other one is much more crude, maybe because of the glow-in-the-dark stuff, I don't know. But this one is much finer, detailed. I haven't tried to print it out in this size with the much finer detail, but I can imagine it's going to look mind-blowing if I can find the right melting temperature for this size. But anyway, we're way past time now, so I will, and I'm getting a little bit tired. You can notice that we're running out of things to talk about, obviously. I saw the chat, there wasn't a lot of things to talk about. So we will continue this tomorrow and do something else maybe, or just watch the stuff that I'll be doing during the day tomorrow. And thank you for watching. Thank you everybody for watching the show. And if you just joined and missed it, we talked about repairing the camera and the making of the battery charger that I made today for the camera, and testing the new materials that I just received for testing the printer and see how we can do things with this modeling stuff. If you like this kind of show, if you want to see it continue, please subscribe and share it in social media with your friends and other people so we can actually watch the subscribers grow. We have had like 1 subscriber extra in like 5 days. So that's not exactly optimal. So if you like this show and you wanted it to continue, it'd be really nice if you share this with your friends and social media, etc., etc. So we can actually see if that counter can grow a little bit. That would be nice. But thanks for watching, and I hope to see you guys tomorrow. We're online every day between 1800 hours and 1900 hours Central European time, Monday to Friday. Thanks for watching. I have been your host, Tommy Helgevold. Take care.